Hey everybody, I'm not anywhere near the studio. I'm at a lake house because we were somewhere for my son's baseball tournament, but you'll never guess what I brought with me to the lake house. A 3D printer. That's the Bambu A2L, a large format bed slinging 3D printer. And the reason I brought it is because I got some new filament from Proto Pasta. Proto Pasta has something called HT PETG. That's right, HT like high temp and PETG like PETG.
Checks out.
And it looks like that. So this material is somewhat like PETG. It behaves a little bit differently. The requirements for it are a little bit crazier. There's a blog post that Alex over at Proto Pasta wrote up that kind of details the process in which he went through qualifying the material and finding what sort of properties he can get with what sort of print settings. My goal is to find out if I can print this on that A2L. I am attempting to print Joel Create's Odd Cube. He just launched a Kickstarter for it, and it is an air purification air filter that has DIY and right to repair built right into it, and it doesn't require special filters. It has off-the-shelf parts. The files he designed are really cool. This is one of them. It's a bunch of triangles that you put together. So I printed this back at the studio a while ago just as a proof of concept because the A2L was loaded with some bamboo green PLA, but I wanted to use something different. So I talked to Alex at Proto Pasta, and that's why that HT PETG came into my existence. On the spool for the HT PETG, it says 265 to 285 C on the nozzle and 90 C on the bed. That is quite a bit more than what a standard PETG is. Now this HT PETG, this is the High Five Blue, and it contains glass fibers. Layer adhesion can be compromised just a little bit if you don't print hot enough. In fact, in that blog entry, Alex had to do some special things in order to get to what's known as full melt in order to get that layer adhesion good. He's doing these little bars. Maybe layer adhesion would be better on dense models. I don't know. Why not experiment when it is gorgeous, absolutely gorgeous outside? Just to make sure I was good to go, I did a print from the A2L's memory, and I was trying to figure out what it was. It's kind of a neat thing. It goes into the front of the A2L right here, and then as the bed comes out, it stops before it. So it's like a bed guard or a bed warning, some sort of thing so that you know this is how far out the bed's gonna go. It printed absolutely fine. So the next step was to try that triangle piece with some HT PETG. That first attempt went okay. I wanna say it's okay. This was a 0.4 millimeter non-high flow nozzle on the A2L. This was 285 C on the nozzle. It was 80 C on the bed, and the A2L can only go up to 80 C, and that's just a limitation, a hardware limitation. So it's not meant for this level of filament, but again, what's the fun in this if we don't experiment, right? So 80 C on the bed, and if we look, bed adhesion was there. Like every part of this did hold on, but I noticed the infill was having some issues. And I know that's indicative of either not melting enough or not going fast enough. So we had to try something else. Next on the list of things to try within the slicer, well, was to change the nozzle. So I brought along some nozzles with me, and this is my own fault. The A2L ships with a stainless steel nozzle, which is not appropriate for crunchy materials, abrasive materials, things like glass fiber HT PETG. It meant I had to try some other things. So I did go with a 0.6 millimeter nozzle. I kept the same temperature and the same speed, the same volumetric flow rate, all of that. And we were still getting good results, but if we look at that part, it has these little nuggets on the straight stretches of this. The flat parts are good, but every once in a while, there's just this nugget here, and
Not good.
And the layer adhesion isn't good. And so I talked to Alex, and he said there's two things that you're gonna run into when printing this that you're gonna have to really, really experiment with. One is going to be the volumetric speed tied to the temperature. And the other thing is the dryness of the material. PETG is naturally hygroscopic and it's going to absorb moisture out of the air, which can compromise the quality of your prints when you're printing with PETG. HT PETG is no different. In fact, I get the feeling it's slightly more hygroscopic, at least that's kind of the gist I get from Alex over at Proto Pasta. So I brought something else with me to this lake house in order to ensure my HT was going to be as dry as it needed to be. And that's the Sunlu AMS Lite heater. You've got a screen up front that you can set various presets. It tells you the relative humidity inside, and then you can set a drying temperature. And then you can set a time because you can dry it for 30 minutes or 24 hours if you want. The AMS Lite fits inside. You take off the stand and you screw this in, and then this top portion screws in right above. It does have its own power source. You plug it in to the 3D printer as you normally would, and there's these vents up top that I think are wonderful because these open and close depending on the power of the device. If you're actively drying, these are open, but if you turn off the power or you're not drying, these vents, they close to keep the inside environment more arid. This is one of those things that's really going to give me my best chance at success. If I can get that HT PETG from Proto Pasta as dry as possible, then at least I can eliminate the moisture of the filament as being something causing issues, and I can focus on speed and temperature. Let's give it a shot. Being able to print materials like PETG on these machines better is always a nice way to go. With the HT PETG loaded, now it's time to dry it. So I'm gonna set this at 70 C, which is its maximum temperature. And what I'm gonna do is dry it for as long as I can, and then we're gonna try another print. And I set forth in printing. So I jumped the temperature on the extruder to 300 C and I just capped it there. I hit go and it came out with this. And we're super duper close. This was at 8 cubic millimeters per second flow rate. And that was the default of PETG for the Bambu Lab settings. And I thought we should just try that, especially if I've got the nozzle at 300 C. That should allow me some decent flow. And it's got some issues. It didn't hold on to the bed in the corners. And that's gonna be on me, obviously, because 80 C is below the recommended temperature, but also I don't have any adhesion helpers here. I don't have any Magic Glue or nanopolymer adhesive. So at least being able to hold onto the bed proper, that might be something that I'm gonna have to solve in the studio later. But the quality is getting closer. The problem with this is you can see these little dots, these little parts right here. I don't know other way to describe it other than zits. And I think that is a symptom of the speed. I know I'm at the max temperature, and also it likes to fall apart. So even though we're at 300 C, I think 8 cubic millimeters per second is too fast for the material. And I think we need to bump it even lower. So what I'm gonna do is go back to the drawing board a little bit, and I'm gonna try 6 cubic millimeters per second, but I'm gonna stop doing full-size prints because those take 4.5 to 6 hours. And instead, I'm gonna do a Chep-Pon. The first test with the Chep-Pon went extremely well. I think 300 C on the nozzle, 80 C on the bed, at least that's the maximum. And then 6 cubic millimeters per second, I think is key. So here's the pon, and here is the purge tower. And the reason that the purge tower is set is because it was doing a time lapse. And if you look on that side of the pon, I think you can see right there, there's gonna be a little bit of an an issue with the seam, and I think that's from the nozzle bouncing back and forth. So with correct settings in mind, I went ahead and printed upon, but without the time lapse. And that's what we got. And it's perfect. It looks so, so good. I'm really, really impressed with it. I think this is the key. So next was everybody's hopefully favorite test model, and that is a 3D Benchy. And this was printed at 6 cubic millimeters per second, 300C on the nozzle, 80C on the bed. That is not bad at all. So it looks like we're in a good spot with this. And now I believe what we can do is try that triangle piece, but at 6 cubic millimeters per second, instead of it taking 4.5 to 5 hours, it's now 6 hours and 40 minutes. So that print was done overnight. When this print was done, this one, the overnight print at 6 cubic millimeters per second, I was ecstatic. I had found the sweet spot for Proto Pasta's HT PLA in an A2L. And at 6 cubic millimeters per second, I'm getting very consistent extrusions using 300C on the nozzle. I don't have that issue of this just coming apart. We're in that realm of full melt and being able to have incredibly good layer adhesion. It's still pulled away from the bed, and I know 80C is below the manufacturer's recommended temperature. I can print Joel Creates Odd Cube, and I can probably do it on the A2L just by adding some Magic Goo or some Vision Miner's nano polymer adhesive. A Sliceworks plate or a Big Tree Tech plate might also be an option for being able to print this material on an open air bed slinger machine. The real benefits are going to show when you use an enclosure or a heated enclosure for this. If you can get a drying solution that dries the filament external to the machine, and then you can feed it through and you get good adhesion and you get good extrusions, then this really cool advanced material from Proto Pasta might just be what works. I'm kind of excited because here I was at the lake house with the family because we were out for my son's baseball tournament, but I brought a printer and I brought material and I brought the Sunlu AMS light heater. And it's fun to play around even when you're on a little bit of a vacation. So, oh, people are jet skiing, cool. It's not often that I get to do explorations in filament. So coming soon, I'm going to be printing the Joel Creates Odd Cube and kind of showing you the ins and outs of that. Hopefully, it's going to be in this HT PETG from Proto Pasta. But for now, I think the experimentation is done. I'm going to go pour myself a beverage and enjoy my last bit of hours at the lake. And I just want to thank you for watching. If you made this far, you're awesome. Don't forget to hug each other more, fight for a cause you believe in, have fun printing all the things. And as always, high five.